Hey Algebra 2 students, this video is to get you a little bit further ahead on this CA. We're going to start with the assumption that you have these numbers, the fact that there are 575,757 ways, different ways to pick a ticket in this Hit 5 winning lottery, where there's 39 numbers and you're picking 5 without replacement, and there's one way to match all 5. There's 170 ways to match 4 of them. There are a little over 5,000 or 5,500 ways to match 3, and then 59,840 ways to match 2. And then we batch the 1 and 0 together because they're both losers. There's 200,000 different ways to match 1 or 0. Either way, you don't win any money. So these numbers are going to come up pretty quickly. I just want to share with you just a quick example of what we're going to do for this number, for the expected value. As an example, if you go to a raffle or like a split the pot kind of thing, and if you've got $2 to play a game and you see that all the different ways to win are, there's a grand prize that's $100, a second prize worth 50, a third prize worth 10, and some people don't win any prize worth 0, and you think to yourself, okay, is it worth it? You always weigh this psychologically. Should I take the chance? Here's the expected value gives you a mathematical number on what your, quote, chances are to win. So say, for example, that grand prize, they're $100, and let's say there's 1 in that whole bin of 100. For the second prize, what was my example? There's 2 out of 100. 2 winners in 100 win. For the third prize, there's 3 out of 100. But that means that the unfortunate losers, there's going to be, after 3, 4, 5, 6, there's going to be 94 people out of 100 that don't win. So when it comes to your profit, you've got a 1 in 100 chance of winning really $98 because you've already spent $2 to play. Got to take that into consideration. You're going to win $48 2 out of 100 times. You're going to profit $8 3 out of 100 times, and you're going to lose $2 94 out of 100 times. This is the fraction, which is the chances. To get the long run average or the expected value, you take the possible payout times its probability and all the different outcomes that could be. So 98 times 100, 48, 2 out of 100, plus $8 you could win, 3 out of 100, but a minus $2, 94 out of 100 times. So what does that end up being? It looks like our expected value, I believe, is 0.32. Hey, that's positive. That's 32 cents, right? Not really. That means that on average, every ticket you play, that $2, you expect to win 32 cents. That means you lose, on average, $1.68. It's bad news. It's not a fair game. But are you willing to take that chance? When it comes to the lottery, it's very similar. And let's get these probabilities here. They're in reverse order now of what we did them with the combinatorics. The denominator for all of these is going to be 575,757. 575,757. 575,757. 575,757. Each time your odds are out of all the possible ways that you can pick a lottery ticket. To win 5, I'll go from bottom up, 1 out of that. To match 4, 170. To match 3, 5,610. To match 2, 59, 8, 40. And to match 0 or 1, the losers, 510,136. Okay, now there's going to be just a little bit of hand waving here because these numbers are so small that I'm going to have to truncate them. That means round them off. So when we add up these probabilities, it's not going to be exactly 1.0, but we'll start at the bottom. 1 out of 500,000 is 0.000017. Very remote. Matching 4, 0.000295. Matching 3, 0097, that's a 9. Matching 2, about 10%, 0.1039. And matching 1, 0.886. About 88.6% of the time, you're going to be losing. So when it comes to, we'll come back to these probabilities later, the average payout, like in this raffle, you could lose $1. You could get your money back, which means you profit 0. You could, if you hit 3 out of the 5 numbers, you could win $10, also known as 9 in profit, and $99. And then the average payout, I think this is published, or it depends what the year is, but on average, it's around $200,000. So find the expected value. Oh, hi.
Who are you talking to?
Oh, I'm doing a video. I'll be right back. To find the expected value, you take $1. We could lose that $1.886. We could win $0. 0.1039. We could win $9. 0.0097. I'm sparing us the fractions here. We could win $99. 0.000295. Oh man, I can't squeeze it in. And we could win that 200,484.0000017. Add all those up. What do you get? Pause me so you can double check. Is it going to be a winner? What's it going to be? What would be the number that would make you decide, yeah, this is worth playing. I know my risk is high, but I'm gonna shell out that buck. What do you get? Negative 0.42. Okay, so this is going to come into play. That's your expected value. You're never going to do that. You're never going to win or lose that 58 cents. But over the long run, if you played over and over and over, your long run average would be losing 42 cents on every dollar. Okay, what's going to happen next, and maybe I'll make another video for this, is the social justice piece on taking that information and applying it to U.S. poverty levels and how, in order to get a winning chance, quote winning, how much would you have to play to ensure a 30% chance of winning?